Hello everyone. So today I'm going to teach you how to do logarithms. Well, logarithms are an, a new topic to most of you because we haven't learned this in the past year before. However, it is coming from the exponential functions which you have learned in IGCSE level and AS level. So let's start from the basic ones. Well, all of those are common sense already, right? Like 10 to the power of 2 equals 100, 10 to the power of 3 equals 1000. And we also know 10 to the power of 4 equals 10,000. However, if we have a question like 10 to the power of x is equal to 7, then what is x? Well, obviously we can't solve it by just looking at it. We need to have something else. That is why we need logarithms to solve those hard problems. The symbol of log, it is just log is just the symbol of logarithms. And most of the equations are written like that. So it's log AB equals C. So what is ABC or equal to? Let's just write in exponential form and you will know what is going on. The a is a base. We call a is a base in logarithms. And this a is actually the a in exponential form. They are representing the same thing. And for b, b is the answer in exponential, which is this. The two b's are at the same place. And the c is the power in exponential, which is this c. So we can see that log is just another expression to express the exponential form. For example, if we have something like 10 to the power of x equals 7, and we want to know what is x equal to, and if we don't have log, then we can't explain that. But if we have log, we can simply write this as log 10(7), which is quite useful when doing questions. Okay, now let's start from the important lemmas. Well, these two lemmas are quite important and you should all remember those two. Well, not just remembering, but also you need to know how to prove these. So log base 10 and 10 to the power of x is equal to x. And for this one, log 10 to the power of log 10x is equal to x for all x greater than 0. Well, before we prove these, let's just do an exercise for just using these two formulas to convert log 10x equals 3.5 into exponential forms. So we have two methods. The first method is quite easy because we have already know that b is equal to a to the power of c. So we can straightly convert this. So x is the b here, which means x equals to, well, a is the 10 and c is 3.5, which means x is equal to 10 to the power of 3.5. We can get this straightly. This is the fastest method. However, we have another method. How to do this method? We need to use this important lemmas by using this one. So because we have already known that log 10x equals 3.5. So let's just assume that because if this is true, then 10 to the power of log 10x equals to 10 to the power of 3.5 should also be true. And now let's look at this lemma, which is 10 to the power of log 10x equals x. So now this can substitute into x, which means x equals 10 to the power of 3.5, and we solve this. Now let's prove these lemmas. The first lemma is log 10x equals x. Well, this one is quite simple because we can use log a base a b equals c. Let's use that. And a is our 10, b is our 10 to the power of x, and c is equal to x. And from here we can see that this logarithm can change into exponential form. So let's do the same thing again, which is a to the power of c equals b, which means 10 to the power of x equals 10 to the power of x, which is correct. That means log 10 to 10x equals x is always true. And we finish the first lemma proof. The second lemma is also quite similar, which is log 10 log 10x equals x. This time let's do the same thing again, because we know a to the power of c equals b, which means now a equals 10 log 10x equals to c and x equals to b. And we convert this by using the log ab equals c form, which means log 10 log 10b equals log 10x equals log 10x, which is also correct. So we have proved both of the lemmas, and these are very important lemmas because by using these you will get 3 other laws, and we are going to talk about them later. So there are some exercise on page 29 in course book, and if you want to do it, you can try them. And now let's dealing with other bases, but it's the same way actually. So the lemmas, we have gotten these 2 lemmas, right? Now we can turn these 2 lemmas into any base, which is log 10 to the power of x equals x. We can change it into log a, and a to the power of x equals x. However, for all a greater than 0 and not equal to 1. Same thing here. We can just change 10 into a because they work exactly the same. Okay, now there's an exercise again. Convert log 3x equals to 2.5 to exponential form. Well, I'm not going to do this. You should try by yourself because it's exactly the same as log 10x equals 3.5. Just remember these 2 ways. Okay, so if you want some more exercise about different bases, you can find more exercise in page 31 in your course book. Okay, now let's do how to simplify log equations such as log base 2 3 plus log base 2 5. Well, in AS level, we have learned that a to the power of x times a to the power of y equals a to the power of x plus y, and a to the power of x divided by a to the power of y equals a to the power of x minus y. And this, we can prove these three laws, and these three laws are very important now, which is most of the log equations are done by those three laws, which is the multiplication law, the division law, and the power law. What is those three laws? Well, firstly, log base a xy is equal to log ax plus log ay, and so when this is times inside, it becomes add. When this is dividing, it becomes subtract. And this one is most interesting, which is log base a x to the power of m, well, becomes m log ax, which we can simply by moving this m into the front. Okay, let's prove these three laws. The first one, log axy, well, the left hand side equals this one, and because the important lemma we just talked about here, which is a to the power of log ax equals x, which means we can change this x into a to the power of log ax and y into a to the power of log ay. Now let's use our skills we learned in AS level, which is that we know that log a bracket a to the power of log ax plus a log ay. This is just equal to that. And we also know that by using this lemma, which is log a to the power of ax is equal to x, and here log base a to the, let's assume the x, let's assume the x here, the x is just equal to log ax plus log ay, and we can get that the whole thing equals to log ax plus log ay, which is the x. And we finished the first one proving. And I suggest you to try the second law and the third law by proving them. And I will post the answers in my next video, because logarithm is actually a very long topic and we need to spend another lessons on it. So if you want to do some more questions by applicating these three laws, you can go to the coursework page 34, which there are lots of questions in it. And yeah, that is all of today, and thank you.